Today's session is going to be about a new solution that we're going to be launching in conjunction with two of our key partners. But first of all, I'm just going to introduce ourselves. My name is Lewis Harvey. I'm the Business Development Manager at Adey Electronics. Adey Electronics are a specialist wireless and 4G, 5G cellular communications company. We've been trading since 2010, and we've partnered with various global manufacturers, including Pointing and Advantech. Been an Advantech partner since 2011, selling primarily their connectivity products, 4G routers, 5G, and then we also pair everything with companies like Pointing. So we do lots of antennas, and we essentially specialize in communication solutions for our customers across a range of industries. Today, we've got Stephen Mooney from Advantech, who's going to be joining us on the webinar, and also Hugo Carvalho from Pointing. So they're going to be speaking about the elements of the solution, and hopefully it's going to be a solution that you can get some benefit from as you move forward with your applications. So a little bit of background to the webinar for today. We often get presented with our customers having problems with connectivity in a whole range of different manners, so mainly internet-based applications, but it could also be private connections as well. So we generally are presented with a few themes that we're hoping to solve with this solution today that we're going to go through. So often, you may see this before, but we get presented with poor signal quality in remote areas, which can cause a range of different issues for customers, from dropouts, unreliable connectivity. We also get presented with issues with customers where antennas are placed in the wrong position for various reasons, and then antenna lengths the cable lengths have to be excessive, which brings a whole range of issues as well. All of these things can contribute to slow speeds, latency issues, which equals a poor user experience. And then finally, because of a lot of these things, you get having to revisit sites, you have to spend lots more money in putting antennas in undesirable places, etc. So we're hoping that this solution today will help you solve a lot of these issues that we're presented with as an integrator and distributor. So these are the things we want you to get from today. We want to improve your installation experience, to improve your communications experience, and to save you money in the long run. So that's our aim for today. And then I'm going to pass you over to Hugo, and he's going to kick off with how we're going to start that ball rolling. Okay.
Thank you, Lewis. Good morning, everyone. Hopefully you can see my screen now. For those who are not yet familiar with Pointing Antennas, we are a South African antenna manufacturer. We have specialized in creating, developing, and manufacturing wideband 4G, 5G, as well as Wi-Fi antennas. In the beginning, military and defense antennas were manufactured alongside the commercial ones, and all were sold under the same brand, Pointing Antennas. Today, the two lines of products have partways and are different brands. You can still get military and defense antennas that were born back then, or from the same company that was born back then. It's called Alaris Antennas, but we are separate entities at the moment. Having our roots in the military and defense really shaped who we are and the way we do things, and I think you can tell when you're using our products. We have a single focus in mind: stable, reliable, and consistent connectivity. And at our core, we've been inventors since day one. We have over 70 patents on antenna and antenna design techniques, and we do this for 5 different markets. Today, we'll be focusing on the market we call machine-to-machine and fixed wireless access. So basically, fixed locations where you need connectivity in a way can be more broadband or more narrow band, but you need a good, stable, reliable connectivity. With this being said, if you probably didn't heard our name before, you probably have heard the name Expol One. This is one of the most, if not the most sold 4G antenna in the UK in the last, 3-4 years, and we are very proud to say we are its inventor and creator and manufacturer. So How can an antenna help your business stay connected? The only way to ensure a stable, reliable, and consistent cellular connectivity is by ensuring that your router has grip to the signal. Without signal, not even the best, most advanced, and most reliable routers like Advantech routers will work. And to do this, we need good quality antennas. Let's use a car for trying and understanding this a bit better. Whatever the car, whatever the amount of money you pay for it, if you use low quality tires, you'll have no grip. And with no grip, you'll have no safety nor comfort. A car journey and the 4G connection can really be compared to each other. Think about the car as being the router, think about the passengers as being the data, and the tires as being the antennas. If the right antenna is chosen, it will provide strong signal grip and ensure that data gets transferred safely and stay in a stable way from point A to point B. On the other end, if you choose the wrong antenna or if it has poor quality, you have weak signal grip and causing not even the most expensive or advanced router not to work as it should. So you need to choose a good, high quality antenna for ensuring reliable and efficient data transfer. But you need to choose an external antenna as well. You do need an external antenna because the signal difference between having the antennas inside of a building or inside of a street cabinet or whatever enclosure where you house your router will lead to a degradation in signal of anywhere between 15 dB upwards. If we're talking about a data center on a basement, that goes even that number goes even higher. So when you're driving around in the UK, you can really tell or get a perception for what I'm saying. When you're driving around in the UK in more rural settings, you'll eventually see people talking on their phones by the window. What are they trying to accomplish? Are they just taking in the views? Not necessarily. What they're trying to accomplish is to get their mobile phone antennas to be as close as possible to the outside without actually having to be outside on the beautiful British weather. In case you're wondering how much of an impact does 20 dB bring to your system, it is enough to take you from what's considered to be a cell edge or a poor connection all the way to a good one. Or if you're in an average location or an average signal level, it's enough to get you to an excellent one. So like Lewis was saying, sometimes we get triggered to, okay, if my connection is poor, I'll go back and install an antenna. But if we do it from scratch with our designs, we always get a positive impact. So something for you to consider. And probably you're now getting, okay, I need to have an antenna, but anything will do. I will add, and next time I'm installing my 4G, 3G is being faded out, but the 4G, 5G router, I'll get an antenna. But anything will do, right? It's antennas, how hard can they be? They're probably just a piece of wire inside of a plastic box. They should be fairly simple. Unfortunately, that's not the case. They're not rocket science. That's a given. But they're just not a single piece of wire or a simple piece of wire either. On first sight, they seem quite a very straightforward and simple product, but they have a number of key characteristics that need to be accounted for if you're looking to ensure that you stay connected as far as possible and in the most stable and reliable way as possible. I won't have the time to go through all of these today, but I just wanted to bring your attention to all these aspects and very briefly touch on what is a good antenna. A good antenna is the one that covers all the frequencies which matter to your application. So if we're talking 4G, we're talking all the way between 700 megahertz, more or less, to 2700 megahertz. If we're talking 5G, we're talking between 700 megahertz all the way to 3800 megahertz. A good antenna is one that has a stable gain across all those frequencies. We're sometimes triggered to decide on our antennas based on the gain, and we think the higher the gain, the better. But do we really know how to analyze and make a decision based on gain? When we see an antenna, we see its name, the frequency it covers, and then a single figure to show what the gain of that antenna is. But in reality, that single figure is just the gain of the antenna for a given frequency at a given direction. So we cannot draw any conclusions out of it. We need to dig a bit deeper. Radiation patterns are the single most important thing for ensuring reliable connectivity. Omnidirectional antennas should be truly omnidirectional, meaning that they need to have the same performance 360 degrees around it, and directional antennas need to have their strongest beam coming from the center of the antenna to ensure that whenever our technicians are installing the antenna, they point it towards the base station, and that provides them with the best performance. Directionality comes from the radiation pattern. Willingness to accept power is what you typically see as VSWR. Just aim for something lower than 2 or 2.5. And then polarization diversity are very much crucial to ensuring the most stable connectivity possible, and the highest throughput possible. So whenever you have a 2x2 MIMO, you should use 2 antennas. You should use a 2x2 antenna, and whenever possible, you should use polarization diversity. Again, I have no time to go through it, but it's very, very relevant. And finally, build materials. After all, the antenna is going to be the one thing which is going to be installed outside, and it is better that it can withstand the weather conditions. As you can see, they're not as simple as a piece of wire. However, you have in us and in Adey the partners you need to ensure you don't need to worry about all of these, and you can just pick up the phone, give a ring to Adey or to us, drop us a line, and we will advise on the right antenna. So tooled with the right antenna knowledge, you're then ready.
Can I just interrupt? Sorry, Hugo. Yeah, I was just going to say, if people do have questions while they're thinking of what you're going through, they can just add it to the chat. There's a Q&A section, and we can pick up at the end. We've got 15 minutes allocated at the end, so we should be done before 11 o'clock, so we can also pick up some of the questions. Sorry about that.
Yeah, absolutely. That's okay. So now you understand you need an antenna, and now you need to make a decision on what antenna to go with. The first thing you need to choose is between a directional and an omnidirectional antenna. This is quite easy to do. There are a given set of references you can use to make the decision. However, a number of times you're not 100% sure of where the antenna is going to be installed, and omnidirectional antennas really are easier to set up and the most flexible ones. Secondly, you need to make sure you have the necessary accessories to install the antenna where you need it. With pointing antennas, this is quite straightforward because we pack on our antennas a number of mounting options. So whatever you're going to install it, most probably you have a solution out of the box. If not, there are other solutions available. And finally, you're going to install this antenna, right? And this sometimes becomes the trickiest part. You need technically capable people who know how to work with the coaxial cables that are going to connect the antenna to the router. You need tools to crimp those cables and devices to measure how well the cable is crimped. You need time to do that work. Running coaxial cables takes longer than standard Ethernet cables, and you will see a decrease in performance the longer your cable run is. And to address all these challenges, we have introduced a family of antennas called the E-Point series. The E-Point 4 is the antenna we will be talking about today, is one of the antennas that belongs to this family. This series. The E-Point 4 allows you to house the router directly inside of the antenna, making for an installation that has virtually no cable loss, due to the fact that the coaxial cables that are connecting now the router to the antenna are very, very short. This solution makes for a much faster installation and a cleaner installation, because the only thing that is needed to run and either to connect the antenna to your infrastructure or the router to your other devices is just an Ethernet cable and the power cable if the router is not PoE. And these two types of cables are way easier to work with. They can be ran for longer distances, and any electrician knows how to work with them and crimp them. So we get not as specialized labor, meaning hopefully some cheaper labor or and specialized one. There's no need for special tooling. There's no need for special measurement devices when these cables are crimped or ready to be used. So all in all, makes for a faster and cheaper install. And finally, it is a pointing antenna. As you could see, we have sold hundreds of thousands of antennas in this space, so we are very much qualified to and can be trusted on this type of antenna. This antenna actually has 3 different types of antennas inside. There are 4G and 5G cellular antennas, which cover all the relevant frequencies being used right now in the UK and basically worldwide. So from 617 megahertz all the way to 4200 megahertz. And there are 2 dual band Wi-Fi antennas covering 2.4 and 5 gigahertz simultaneously. So if you want to create a Wi-Fi hotspot around your router, you can do that for operational, just a operational SSID or something to provide Wi-Fi to guests, and the GPS antenna as well. There are 2 versions of this antenna. One is for two cellular connectors. So it's a 2 times cellular, 2 times Wi-Fi, 1 times GPS, and you can use it with 4G routers like the Adventech that Stephen is going to present today. And then regardless if it has Wi-Fi or GPS or not. And then there's a 4 times cellular, 2 times Wi-Fi, 1 times GPS, designed for 4x4 MIMO LTE routers and 5G routers. As for performance, a very stable gain across all the frequencies that it covers, around 1 dBi more or less for the frequencies between 600 and 2700 megahertz, and then it drops to around 0 or minus 1 dBi. You may think these are very low gain figures, but bear in mind that first you're bringing the router outside, so or you're bringing the antennas of the router outside, so there's already a 15 dB gain on doing that, and then of course you have no cable loss. So the impact, so if you take the difference between using the antenna or not using the antenna, or using an antenna with indoor connectors, indoor antennas, the difference is big one. Louis, do you want to add something? No.
I was just going to put some figures on that, just to give people who are watching some example figures. If you're looking at sort of a lower grade quality cable or something like an RG174, you could be looking at about 1.3 decibels of loss per meter. So if you're trying to get your antenna cable into a building and you're using a 10-meter cable, then you could be inducing sort of 13 dB of loss on your system. So it can be a massive amount of change, really. So just wanted to add that, really.
Oh, thank you. Then you have, of course, the VSWR pretty well controlled, and here are our radiation patterns. As you can see, the azimuth tells you how well does, so what's the performance 360 degrees on the horizontal plane, and the antenna shows that it's pretty much omnidirectional, 360 degrees around it. And on the elevation radiation pattern, you can see how the gain behaves a bit over the horizon and a bit below the horizon, just as you would expect from any of these, from good omnidirectional antenna. We have the measurements for the Wi-Fi, elements, antenna elements in the antenna as well. Just want to highlight that all this information is coming from truly measurements on the products that are exactly the same as the products you will receive. So it doesn't come from a simulated tool, doesn't come from a specially built antenna that it's then measured to create the technical sheet. No, these measurements come from a production unit, commercially available one, just like the one you receive when you get one of our pointing antennas. As for mechanical data, real quickly, 1.2 kilos or around 2.6 pounds. It's the weight of the antenna. It measures, if including the wall mount bracket, 35 centimeters. It's 35 centimeters tall and 24 centimeters wide, give or take. It is, of course, built for withstanding rough weather conditions with a high wind survivability rate, IP67, IK10, so you can be very comfortable with putting your router outside. salt spray protected, UV stable plastics. Plastics is the materials that the antenna is built from. So something I didn't mention, but something worth mentioning at this stage, we actually manufacture maritime antennas as well. So we have a lot of experience on these type of antennas, and this antenna in particular is one of a very few selected antennas that we have designed especially for maritime and inland applications. So if we've designed it for maritime applications, you know it will work. As to how big of the router can you put inside of the antenna? The antenna can accommodate routers up to 140 millimeters to 120 millimeters by 50 millimeters. And then, as I said, there are a number of mounting options you can work with out of the box. There's a pole mount included. The same type of mount comes with the screws that you need to mount it to a wall. Then there's a flat surface mount you can use, and there's a marine bracket mount as well, which you can use. That we sell the adapter on the side. All in all, this is a very flexible product that intends to ensure that the best possible 4G and 5G connectivity for all types of applications and installation scenarios. It does so while making sure that the installation is also very simple, very cost effective, and ensuring a flawless performance. We do know, however, that antennas are not a one size fits all, so there are plenty of other options in our portfolio. Some are directional antennas, others are omnidirectional antennas. You see that we have a couple of other E-point antennas, so there's a directional E-point if you want to make use of a directional antenna. There are other things with other form factors, more rugged, bigger, smaller, that you can install on all sorts of applications at different price points. So it really depends on the need and on the application, but for sure you'll find the antenna you'll need from our portfolio. Thank you.
And if there's anything anybody's unsure about, then you could always just drop us a line and we'll be more than happy to recommend something. If this doesn't totally suit your application, we'll have something that works for you.
Absolutely. Stephen, you can take it from here.
That's great, Hugo. Thanks very much. Let me just share my screen now. Okay. Right. Is that visible for everybody?
Yes, it is.
Yeah.
Okay, excellent. Okay, right. Good morning, everyone. Hugo, thanks for that, and Lewis, thanks for the introduction as well. I'm just going to run through just a very few brief slides here to show you the other element that forms the overall hybrid solution here, and that's, of course, the cellular router that goes inside the pointing antenna. It's an industrial cellular router. It's our ICR 2000 series. We have quite a few range of SKUs and variations of the ICR 2000, which are very much optimized for specific types of functions. Whilst they're targeted at a more entry-level market in terms of pricing and so on like that, the fundamental capabilities inside the routers and functionality that you get with them is just the same as our higher grade cellular routers that are many times more expensive in scale. It's an industrial platform, of course, as opposed to a commercial one, which is critically important. People will often think, well, I can just use a commercial off-the-shelf one and away we go. But then often it will fail in harsher type of environments. And you can actually see in the graphic here in the background, you can actually see the types of environments where we have our cellular routers operating in. So they have a wide industrial operating range of between -40 and +75 degrees. In fact, the storage temperatures go even beyond those kinds of specifications. So they're very much industrial in nature, and when combined inside pointing weatherproof enclosure, antenna enclosure, it truly provides an all year round, all weather type of outdoor device. It's got extremely low power consumption, for example. I mentioned DIN and wall mounting here, although that's kind of a moot point considering that'll actually be inside the pointing antenna itself. This is our V2i platform, which is a replacement for our older series of V2, which have been extremely popular with the industry for many, many years. So we've brought it up to date with a enhanced CPU power, a little bit more memory and so on there, so we can accommodate more of our applications called router apps in there. So just to show you a little bit then of the range of types of SKUs in here. So a lot of these look kind of similar. There's the obvious variations of 1 and 2 and 4 Ethernet ports on there, but you're getting ones that for different regions. So you've got complete compatibility and compliance across all the EMEA region, North America, Latin America, for example. But we do different kind of SKUs of that as well also. There's ones in there, for example, that specialize at 450 megahertz, for example, with LTE. But not only that, but there's also narrowband and LTE Cat M1 cellular modems in some of the variations as well, which provide for even further extremes of connectivity issues when you're looking for very, very deep building penetration, or indeed actually into extreme rural connectivity types of situations. There's also a private LTE version as well in there. So multiple different types. They all look vaguely similar, provide exactly the same kind of function pretty much, but are tailored for individual specific geographical markets and a few different radio access technologies like NB-IoT and LTE Cat-M. Having really good connectivity, as Hugo mentioned, is extremely important, right? It's those tires in the car. You've got to have that kind of connectivity. Without the connectivity in there, you know, there's not much that you can really do for your remote assets, right? So having that really good link budget that's provided by an exterior high gain omnidirectional antenna is extremely important. But equally important in there as well is what the cellular router can bring to the overall solution for that connectivity. That connectivity and that high availability that we like to talk about for the assurances that your services are being transmitted from your remote locations into your central location, for example, is often built into a lot of hardware and software functions. So I mentioned a little bit about the industrial nature and wide temperature operating ranges that our cellular routers are designed for. But then when we look at other hardware aspects, we see things like dual SIM cards, where you can have multiple SIM cards from the same or different providers. Some people wonder why you might even have it from the same provider, but often it can be the case that it's not even a failover between one SIM to another for a connection issue, but you may have exhausted the amount of data limit that you might be confined to on your particular plan with one SIM, and then you can fail over to the other SIM to avoid excessive or out of plan charges. The cellular module that goes inside our cellular routers themselves, they are 4G. There's different types in there, but they are 4G, but they do an automatic fallback to 3G and then into 2G as well again. This is something that's completely transparent to the user and the operator. However, though, we do provide functionality in there where you can manually tailor which radio access technology that you would like to use, and indeed which frequency bands right to use. So you can actually force the cellular router to choose those types of frequency bands. Clearly, there's got to be a mobile network operator that are offering those radio access technologies and frequency bands in order to be able for the router to make a connection to the mobile network radio access network. When we move away from the hardware side of things, so we've got a great gain, great omnidirectional gain from the pointing antenna, combined with a high quality industrial cellular modem inside the cellular router. Then you can bring layers of higher availability functions in there through software. So often we have things, for example, like different routing protocols, like virtual route redundancy protocol, RIP, OSPF, next hop routing protocol. There's a multitude of different protocols in there that will allow you to ensure your kind of connectivity and integration with not only your network, but also third-party networks as well. Because indeed, all these functions are implemented as per the standards. We don't do anything proprietary in that nature. And that brings in the best possible integration that you have with your existing infrastructure. We do default routes, backup routes. You see, we call them cellular routers. You see them there with a number of Ethernet interfaces, But in fact, actually, it really is a rather smart embedded computer that has multiple interfaces, namely Ethernet and, say, for example, Wi-Fi, or indeed, of course, cellular. Any of these interfaces can be decided to be which is your WAN interface and which ones are your LAN interface. And not only that, you can then decide, well, I could have, cellular router. Ethernet might be, for example, your prime WAN interface. But you could decide that I will have the cellular interface as my failover backup to my Ethernet WAN interface. So you can decide the priorities of which interfaces are your WAN and LAN, and also the failover, and according to your preference, about how you'd like to maintain your remote network connectivity. So that's what we decided was user definable priority for fallback. We can have automatic firmware updates there as well. So you can find if there's any bugs that have been identified within software or there's enhancements in there, you can have automatic updates in there, so that without virtually very minimal user intervention, you can have those automatic updates and patches into your operating system, the firmware that runs on the cellular router. It is, of course, prudent to go and test these things beforehand to make sure that it does fit indeed with your environment. But you rest assured that Advantech do the deep retrograde analysis to make sure that the firmware will provide at least the same connectivity as before, but if anything else, but enhancements and refinements to it. I mentioned there, of course, a little bit about our user module we have, our router app, which allows you to pick and choose which frequency bands and which radio access technology, be it 2G, 3G, or 4G, that you would prefer to use. Having connectivity, of course, is one great thing. Having highly reliable connectivity is even better. But again, of course, in this day and age, we need to consider high availability with security. We cannot leave any of these things out of the triad at the end of the day. So our cellular router, even though this is our entry-level cellular router, it supports all the same functions that you get with our high-end routers as well. So we support a different range of tunnels, for example, like WireGuard, IPsec, OpenVPN, Layer 2, generic routing, point-to-point, and all these are implemented as indeed per the standards. So if you have a third-party piece of equipment that's using IPsec or WireGuard or whatever it may very well be, you can be rest assured that the functionality that's implemented inside the Advantech industrial cellular routers will provide excellent levels of interoperability with other third-party equipment, so long as they also adhere by the open standards that are in there. That secure connectivity is augmented, of course, as well. We have a very granular firewall. We can filter everything down from source, destination, IP addresses, ports, protocols, you name it, it's all on there. It's completely granular. You can be absolutely as razor sharp precise with exactly what connections that you want to be able to provide in there. We have enhanced source and destination NAT functionality built into the cellular router as well. And of course, it goes without saying that we have a security team inside Advantech that aggressively evaluate the security posture of our industrial cellular router, and will evaluate that against current vulnerabilities that are announced and so on within inside Linux or any other aspect of components that we use inside the cellular router. And they will work to address those particular things, and then we will freely release those bug fixes as and when they're required. Augmented edge functions. So it's been quite some time ago, 10, 15 years ago, we considered a cellular router just a box that provided you, well, RF connection on one side, and then you had some sort of LAN connection on the other. And that was pretty much it. It was just a wireless bridge, to a cable network on the far end. But as you can imagine, even though this is an entry-level cellular router, for example, of our V2 range, which then of course we have V3s and V4 ranges, there is they're quite more powerful, considerably more powerful than the ones were 5, 10, and 15 years ago, certainly. So just like with a smartphone, where you can take advantage of customizing your phone to the function that you require by the addition of apps from your preferred Play Store, for example. Advantech have the same concept with our router apps, and we provide nearly 120 freely available router apps that allows you to very, very easily, with just a few mouse clicks, there's a few different ways to do it, but it's as simple as a few mouse clicks to add in additional functionality. So you can add in different types of protocols. You can even add in different programming environments, for example, like with Python, for example, and even on the more powerful cellular routers, Node-RED environments, so an entirely flexible, open sourced environment that you can go and work with. We do also support, of course, industrial protocols. Being an industrial cellular router in the industry is our prime focus, where we have Modbus, RTU, lightweight machine-to-machine, DNP3, message queuing, telemetry transport, a whole variety of protocols that can be added in there. So you can really build upon the functionality of the excellent firmware that's already baked in. In fact, we have many customers who will come to us and they will, either with our assistance or directly through themselves, will develop their own custom app, just like many people do for smartphones nowadays. We provide the source code, the tool chains, and so on like that, and guidance and instructions. And we have many customers who create their own customized app to run on the cellular router. We can also do that for you as well. That's another possibility inside Advantech can do that for you if you don't have the capability in-house. But also one of the things that we have is that through bash scripting with startup and shutdown scripts and so on like that, you really get a Linux environment to be able to play with in there and really create your own functionality. So we have many different levels of additional functions that can be brought to what was just considered a cellular router. So you can see that cellular routers, industrial cellular routers, have moved on quite considerably from what they were as just a remote connectivity modem type of device. So we have here, of course, having many assets being remotely connected, for example, brings in many challenges in terms of, brings many challenges in terms of not just connectivity, of course, but in management and provisioning. If we think of the IT enterprise world today, you can imagine there's tens or hundreds of thousands of remote endpoints of desktops, laptops, and so on like that. And you simply can't afford to have somebody, some technicians moving to different locations and physically sitting at each individual unit. So similarly in the OT world, the industrial world, especially when we consider the remoteness and the difficulty of some of these locations where we have that remote asset, for example, like the combined Advantech and Pointing product together, is that you need a centralized management platform to be able to coordinate all those assets. And in Advantech, we have our web access DMP for device management and provisioning. And that brings it all together and gives you as a company owner a huge overview of your entire network estate. You see GPS locations, everything. In fact, everything that you can physically do if you were plugged in to a cellular router, one of our cellular routers, you can do through the web access DMP platform. In fact, actually, you can do even more. So we have great capabilities in there. For example, it's all done through secure management, of course, and the reporting that's done in there as well. We have this concept of, you know, a digital twin where you will have a digital version of that in your management platform, and then you have the actual asset at the end. And you can freeze that. You can say, for example, I want all these parameters frozen. They're just the way I like. The LAN addresses, the security ports, the types of radio network I want to connect to. You can freeze all that. And then what happens is when somebody goes to the field, they can almost have a zero-touch provisioning capability where they insert a SIM card, you know, for example, and they put power on there, and obviously the antenna will be connected inside the pointing antenna. And the device will power up, it will authenticate back into the centralized network and pull down its configuration. And even if someone accidentally misconfigured, you know, or there was a malicious actor involved there where, you know, your assets were compromised, whenever there's a connection, and we'll always try to make a connection back home to the DMP server, whenever a connection is reestablished, DMP will see that there's a difference, for example, which we reference here as being not in sync, for example. We can see it's online and not in sync, and we can just say, well, that's not the correct configuration for that device, and it'll automatically force it back to the pre-approved configuration that you have. This is a great thing in terms of security and assurance of your remote network assets, especially when it's something that you can't necessarily get to. And it prevents you having to do many multitudes of often very onerous and difficult field trips. Other things you could do, of course, is mass bulk provisioning. You may have an estate of 10,000 or 50,000 devices, for example, in 3 or 4 different categories of devices. You might have a golden configuration for each category. So you've got 3 great, configurations that you want to deploy. You can simply group, very simply and quickly, group all your devices that you want into one category, apply one configuration to them, and Web Access DMP will deploy those configurations out remotely to all those particular devices. And you can do that there and then on the spot. You can do staged configurations. So you could deploy X amount of assets at this time frame and Y amount of assets in a different time frame. It's entirely flexible, up to you to do. Web Access DMP itself is, even though there's a fantastic GUI that we have that's very simple and very easy to use, and there's a huge wealth of data with signal strength analysis, the amount of carriers, you name it, it's all there in front of you. It's actually all driven through APIs, so application programming interfaces, and they're open APIs as well. So we can have actually machine-to-machine types of communication. If you have an existing BMS, for example, system that you might have there, OSS, BSS type system in there, and you want to integrate that through for, let's say, work ticket generation, whatever it may very well be, you have an overall umbrella management system. Well, you can use the open API interface of Web Access DMP and get an immediate view, a detailed view of your entire estate of remote assets that form part of your network. Now, Web Access DMP is on generation 2 at the moment, and very shortly we're going to be bringing out Web Access DMP generation 3. So do stay tuned for that. And that's pretty much where I wrap up my presentation there. Lewis, back to you. Lewis?
Not sure you're talking or not, Lewis, but you're muted.
Yeah, I'm just taking over now.
Oh, yeah, there you go.
Can you see me?
Yeah, we can see you.
Yeah.
Okay, perfect. Perfect. So I will just summarize the last part of the session. Okay. Okay, so you see my screen?
Yes, we do.
Yeah, perfect. Okay, so just to summarize what both Hugo and Stephen has said just now, what we feel we can help you with this solution is reducing some of the technical headaches that you may have with existing or planned deployments. The MIMO antenna that Hugo's gone through, which I will show you here, is a lovely box. Let me just turn my background off. There we go. So this is the box here, and you can see if you open up the inside, you can see how short the cables are for your router to be connected to. This has a massive benefit for you because if you're in a tricky environment where you've got to run lots of long antenna cables back to a router inside a building, you're going to be losing lots of signal from the antenna. With this application, we just place the router on the base plate, which is sort of this size. So we just place our little router in here, sits on top there, and you've saved yourself a lot of cable loss on the application. That in itself will be able to save you quite a lot of decibels and improving the amount of quality signal that goes down to your application.
And once everything goes together, this is how it looks, the final look and feel of the antenna. So yeah, quite clean. Cables come down from here directly into the mounting pole, to the mounting bracket to the pole, and then they just go into the wall or into the pole or whatever, or you can just flat mount it. Just once you close it, this is how it's going to look.
Yeah, so it's a sealed unit, and you can do a lot of the harder work back in the offices. So rather than spending a lot of time on site, which can be expensive, it can be awkward to be working around other companies, you can get all this done configure all your routers into the antennas and get them ready. So all you have to do is just connect the power and the Ethernet cable into it.
Yeah, and one thing I was discussing the other day regarding one other type of our antennas that's like this, that houses the router inside. You can even, out of the factory or out of the shop floor, you can put a little RJ45 pigtail or Ethernet pigtail, right? And then with a female RJ45 or plug. So this way you allow enough cable, and then you can just leave the rest of the cable. Can even be an indoor Ethernet cable. Doesn't need to be an FTP or SFTP outdoor, which are more expensive. So my idea would be just little cable with RJ45 female plug here. And then that goes into the pole or into the building, and then you just finalize your other cable. And this would mean actually that you wouldn't have to open the box, so installation would be exactly plug and play.
Yeah, and that paired with the ability to manage the device via DMP, as Stephen was mentioning, means that all of your devices, the router and everything can be, once it's locked into that antenna, you already know that it's pre-configured and you can manage it remotely, so you don't have to keep revisiting anything on that site. So hopefully it saves you a lot of money because you've got all the management completed by the software platform. Everything's pre-configured in your offices, and then it's the case of sending an engineer just to connect a cable onto site. So you've got that robust connection, you've got a better signal quality, and you've got the reliability that we've been through. So what we are able to do after this session today is introduce it to the market. But these are the markets where we think it's going to be more suitable to. These are our markets that we sell a lot of the existing Expo antennas and these types of routers into. But for infrastructure, for transportation, energy, primary and backup internet applications for offices and retail environments, a lot of leisure applications we work alongside, and then hospitality environments as well. So we believe it's a perfect solution to help solve some of these issues that we get presented with on a daily basis. So the final bit for us, just to let you know, we are supplying these now. So they're both fairly new products, and we're going to be pairing them together for a special sort of launch offer that we're going to be bringing to the market from today. So you can get this from our website at the moment, or you can call or contact us directly. If this solution doesn't work for you, if you need something slightly different to it, then obviously feel free to give us a call or drop us an email, and we'll have something that we'll be able to pair together for you to solve your problems. So we'll always have something. This is our specialist area with 4G remote connectivity. So if you don't want to trawl through all the data sheets and be confused by all the part numbers, just give us a call and we'll be able to help out, hopefully, for you. So I'm just going to pick up, if anyone's got any questions, please, you've still got time to ask them into the chat, but we did get a few earlier through the session, which I'll pick up on now, just for everybody's benefit. So if you do have any, just drop them into the chat now. We did get asked earlier about a directional model, and Hugo did mention it in his presentation. And if you look on this slide here, you'll be able to see this is the EPN-T2, the E.2. So it's essentially the same product that Hugo was showing and what we had out here on the desk, but it's a directional version of the antenna. So instead of having sort of 4 or 5 dB of gain at peak in all directions, this one can go up to around, I think it's 11 dB of gain. Is that correct, Hugo? Something like that?
On the higher frequencies, that's it, exactly.
Yeah, so we do a lot of the Expo 2s at the moment, which doesn't have the router in there, and that requires you to put them on the side of a building and really focus them onto a specific area. But obviously you've got to then put your cable into the building or wherever your router's housed. Whereas this EPN2 will help you focus your beam onto the base station. I believe it's something like a 20-degree beam width, something like that. I don't know. So it's very focused. It reduces the noise of the other frequencies down. So it does make a huge difference. So that's another option for this antenna solution as well. So people can contact us about that, and we'll be able to put a solution together for you. One of the other questions we got asked earlier on is, do we have a PoE version? And yes, we do have a PoE to fit within this antenna. So if you're interested in that, we had a couple of requests for that. Just drop us an email and we'll come back to you with a solution. But yeah, there's lots of options we've got to power the unit. And then finally, we had a question about web access DMP, which I think is one of the key elements to make this solution unique, is the fact that you can manage it all remotely and you don't need to revisit anything. We were talking about, someone asked if you could have the routers log files be presented on the cloud management platform, and that is actually coming in one of the future releases. Stephen, I don't know if you know when exactly that's coming, but I do know it is coming.
Yeah, you're correct. I mean, DMP itself has a huge audit and logging capability built into the platform itself, of course. And then, of course, we have the report files from the cellular routers themselves, which are great one-stop shop text files when it comes to debug, because it contains your entire configuration and kernel log reports and connection log reports and stuff in there. So we'll have that in Web Access DMP version 3, which we're going to be releasing in the next couple of months.
So hopefully you've got an option now to really help improve your connection out on site and reduce some of the issues that you may have been presented with. And if you're in a planning stage, an early planning stage for a project, then this hopefully gives you an advantage to consider with a lower cost industrial router and a great antenna. Hopefully it's the right package to help you kick on. So please feel free to get in contact with us after this webinar. We'll be sending out the slides for all those that have attended, and I believe the recording of it will be available soon in the next few days. So, and then obviously our contact details, you can get them after the session as well. So you feel free to contact us. Okay.
Yeah, brilliant.
Well,
thank you.
Well, with that,
you,
just want to say thank you to Hugo from Pointing and Stephen from Advantech for joining us on this session. Much appreciated. And thanks for everyone for attending, and hopefully it was useful, and we will all speak to you soon.
Thank you very much, Lewis. Thank you, everyone.
Thank you. Take care.
Thank you.
Have a good day.
Bye.
Bye-bye.
Bye-bye.